Alrighty, Hacksters. It's been a while since we did a live stream with anything other than interviews, and I wanted to wrap up this Oskitone synthesizer soldering. So we're going to do a late night, Friday night soldering session and try to wrap up this. In case you don't remember from the last time, the Oskitone Scout is a synthesizer, a DIY synthesizer that is very friendly to people who want to tinker with it. So you can 3D print your own pieces for it. Let's go to oskitone.com. This is created by Tommy Marshall in the Bay Area, and he's got a number of different synthesizers and other types of sound objects that you can tinker with and create in your own desired image, including this Poly 555 synth, which I think is amazing. It's 25 555 timers built into a synthesizer, which is just incredible. And I really want it. But what I have for now is this synthesizer that we're going to put together. The Scout is fully open source. You can find it on GitHub at the link in the description below. Here's a better view of it, how it'll look when it's done. Of course, it'll be yellow. Also, here's the instructions that I'm following, the assembly instructions, also linked in the description, as well as our interview with creator Tommy Marshall, who tells us a lot about the backstory and also the how he went about prototyping it and producing it as a product. So there's some stuff in there for you as well if you want to do any kind of hardware small business. And then we also have our previous video where I started assembling this kit, but it rapidly it was a little bit long for a single session. So that's also linked in the description if you want to see the assembly from the very beginning. And finally, I wanted to show you Blitz City DIY. We're going to have her on for an interview in a couple of weeks, and she's been doing a lot of cool stuff, playing around with making her own version of the Scout synth, as well as other things, but she 3D printed her own color of keys and things of enclosure for this synthesizer. So I think it's really cool to see how she's done that. But we're going to finish putting together this one that I have here today. And let's go. I'm going to follow these directions at oskitone.github.io/scout. And where we left off was with this little test that we were doing to make sure that the Atmega microcontroller was working all right. So I'll start with showing you that, and then we'll move on to the next step where we start soldering on the switches, which is very exciting for me because I want to get this up and running and play with it. So here we go. Oh, my soldering iron is unplugged. Let me fix that real quick. That's why I'm not getting any heat. Anyway, you can see this, how much it's already assembled. Let's walk you through what we've got up to this point. Failed to switch camera. Oh, camera issue, that's why. There we go. All right, so here is the desk. It's a Friday night. You know how this is going to go. It's going to be a little bit wobbly. But yeah, here is our test from the last time. You can see the Atmega has come on and is controlling this LED. It's a little RGB LED that we soldered on last time that has blue and green blinkies happening, and that indicates that the chip is working. We also have our yellow enclosure for the Oskitone Scout. These were graciously sent to me by Tommy Marshall. And again, you can find the interview with Tommy in the description below. There's 3D printed knobs and switches and things, all kinds of stuff. And there's also a chip, another chip that's going to go on here. We're getting a little bit of shakiness, but I think that'll be okay. And then on the left here, I've got all these other components that are going to go on here, and my little bag of switches. So maybe I'll dig one of those out because that's what we're going to start with. Let's just dump them out all out on here. I've got my lead-free solder, and on top of that I have my tip cleaner, which helps keep my soldering tip nice and non-corroded. And I've got my brass coil over here. Let's put that down there. Oh, spring might be from there. We also soldered together this battery pack. This is pretty cool. The battery pack is also something that's 3D printed, and then you put in the little springs and things so that it becomes a working battery pack. and it shipped with the 3 AAA batteries that it needed. I'm using this Omni vise, which is a really nice vise for putting together PCBs and stuff. It's very hefty. It holds it's very stable. I've put a couple of rubber feet on the bottom of it to tilt it forward so that it doesn't reflect light back for you. Okay, so let's try starting to put this switch on. These generally work really well. You can see they've got these little leggies that kind of bend so that you can keep them situated in the PCB. Are we out of focus? No, we must not have focus problems. Let me adjust this. There we go. Much tastier. Beautiful. Okay, there we are. So we're going to stick these little leggies through the PCB, and I'm going to double check which pins we're going to do first. Okay, so we're doing the far left switch, aka tactile switch, aka momentary switch, aka button. Such good clicking. Let's go solder that. Are we hot enough yet? Come on, soldering iron. I gave you a whole little intro there. There we go. As always, I sort of, I pick up the whole roll of solder and do this because it's pretty light. But of course, as with any time I'm soldering, I'm going to need to wash my hands before I eat anything. Even though it's lead-free, that doesn't mean it's free of any toxins or whatever. So you always want to wash your hands after you do soldering, even if it's lead-free. Okay, let's see how this goes. I think that I'm supposed to oh yeah, there we go. So when I click this, it again blinks a different color. And that means that it's working. And I'm supposed to power it off again. Next up, we are supposed to make some noise. So we solder the volume potentiometer, RV1, resistor R3, and headphone jack J1. Ooh! Exciting that it's time to listen to stuff. Okay. Oh, I wish I had a little speaker for you. That comes later, actually. There is a speaker included in this kit, but let's go find the volume pot. Resistor R3, which is a 10 kilo ohm resistor. Is that this guy? We've got 10000. Yes. And a headphone jack. That's this guy. Make sure that RV1 and J1 are pushed into the PCB all the way before you solder them. You can use a bit of tape or blue tack adhesive to hold J1 in place as you solder. That's the headphone jack. And then you connect your headphones into the headphone jack. Push firmly until it clicks in all the way. Okay. So I'm going to do, let's do the resistor first. This is R3 if I'm not wrong. Yes. RV1 and J1. So R3 is over here. I'm going to do that first because it's a little shorter than the potentiometer here. Oh, that's the headphone jack, isn't it? RV1. Oh no. That's the volume. And then over here is the headphone jack. Hey, Gustavo. Yeah, it's definitely late on Friday night, but I'm glad to see that some people are hanging out and down for a soldering session. I find that at the end of a long week, it's kind of nice to have this wind down session. Ugh. Let's push those in a little bit. It's kind of like lo-fi soldering videos to study/relax to. And it does seem a little lo-fi. We've got a little bit of slow video going on, unfortunately, but just think of it as lo-fi. I'm going to leave that out for now. I'm going to do a little tacking trick that I can do. I'll show you that in a moment. Okay, so we've got this resistor. capacitor. I try to sort of wick the excess solder up the leg of the component. Helps make a cleaner solder joint. Ideally, you wouldn't have any excess solder there, obviously, but if you do, you can just drag it up the leg there. There we go. And these little pins on our potentiometer. One of the little 3D printed accessories, as I pointed out before, is a knob top for this potentiometer. Very exciting. Okay, let's cut that off. That means finding my nice side cutters. Here we go. Yes. And I try to hold onto the legs as I clip them so they don't shoot off everywhere. Okay, so now we will do the headphone jack, but I'm going to do this a little weirdly. I'm going to place it in the pins, and since it doesn't hold itself in there, I'm going to hold it in place. I'm still going to attach it in here a little bit just to stabilize. I'm going to hold it in place. Make sure that my finger is very safe from any heat because I'm going to put some solder on my soldering iron and sort of cheat by tack soldering one of these down. Just enough to kind of hold it in place. There we go. Now I can solder the rest of them in, and I'll come back to that one and make it back into a real solder joint once all the others are in place. As the assembly instructions note, though, you can use a piece of tape, double-sided tape or blue tack to hold it in place. I find it's less bother and a little bit easier to just do a little tack solder joint, and that keeps everything nice and aligned, and you don't have to worry about, it falling off because you're holding it in place. There we go. So ideally now I would have my speakers all ready to go. And indeed, let me try actually plugging my headphones in here and turning the volume all the way up. I want us both to be able to hear it. So, Pavan, this is a synthesizer kit, a DIY synthesizer kit called the Oskitone. I'm going to plug this in, and we are about to test it to see if it will make some noise. So, connect your headphones into the headphone jack. Turn the volume up with the potentiometer and press SW2. Once I have the power on, this should work. This is clicked in all the way. Okay. Oh yeah! I don't know if you can hear that, but I can hear that. The switch is making the audio go. That's really cool. Nice demo. Later on, we're going to solder a little speaker into here, so I won't have to worry about using my headphones for that. All right, so back to the assembly instructions. What's our next step? Get loud. Ooh, we're going to solder some capacitors and wire the speaker in. Yes, okay, cool. So 220 nanofarads, or microfarads rather. That's this one, big one. You can find the value up here, and you can see that this is the negative side. Cut that off with the tape. That's obviously this large capacitor. And the round side / the white side aligns with this white negative stripe on there. I also cheated and took a look at the assembled version in the instructions. Okay, cool. So that capacitor is going on. We're going to do C6 as well, which is 0.1 microfarads, marked 104. That's another one of these little gumdrop ones. Now where's that going? C6. C6. There we go. And we're going to do resistor R4, which may be blue. That's this guy. Ha, cool. R4, where are you going? There you are, down by the headphone jack. I'm really glad that I decided to look at the assembly instructions for this, because generally, as I mentioned before, with kits, often what I'll do is follow this standard procedure where you start with the shortest components and work your way up to the tallest ones, because that way you sort of don't get in your own way. But the cool thing about these instructions is that Tommy has built in tests and checks every step of the way. So every few components that you solder on, you're actually going to get a new effect as a result. Like you test, to see that the little light is blinking. You test to see that it makes sound through headphones and stuff. And we're going to test that it makes sound through the speaker. And then we're going to do all the rest of the switches. And it's really cool how he's built in these little sort of aha moments all along the way, so that it doesn't feel overwhelming. I think if you were a beginner at assembling electronics, this would be a very approachable kit, because you can tell instantly if you need to go back and fix something. It's not like you're going to get the whole thing done, and then at the end, after putting a couple of hours in, you're like, oh no, it doesn't work. It's like you'll be able to tell right away pretty much if something isn't connected properly, and that way you don't have to debug the entire circuit. You only have to debug the last few steps that you did and make sure that those are soldered in well. So I think this is a really amazing kit. Okay, so now we're going to put the speaker in, LS1, thread the remaining ribbon cable through the hole. That's this. We're going to strip the insulation and solder to LS1. Okay, so I'm going to flip this over. The hole that he's talking about is this one. I'm going to use my fingernails to separate the two. There we go. You can also use a side cutter to do that. Strip it. Let's see. And solder to LS1. Okay, that's right there. Excellent. I'm going to twist these a little so that they don't come apart going through the hole. Close enough. Now, technically, speakers like this do have a positive and a negative terminal. However, in practice, it doesn't really matter, because what's happening is that there's a membrane that's being caused to vibrate at hundreds or thousands of times a second. And you're not going to hear the difference between whether it starts on a pulling in or a pushing out of air, which is what it does. Okay, so we're going to strip and solder the other ends to the speaker, matching the positive and negative sides. Again, I wouldn't worry too much about actually matching the positive and negative sides of this. Like, for example, I've got the gray one in positive here and the purple one in negative. And on this speaker, I probably don't have to keep too much track of which one is which, because again, this thing is vibrating hundreds of times, at least per second, in order to produce sound. And the only difference if you change the polarity is that it will start by pushing that membrane out or by pulling it in, because you're powering this electromagnet. So based on my understanding of how speakers work, which I'm pretty confident in, but not 100%. So we've got this 0.4 watt, 8 ohms speaker. Let's solder this in first, actually, because I'm not fully confident that those will stay in if I keep monkeying around with it. And I'm going to be lazy and solder this from the top, because I've got those stuck in there and I don't want to pull them out when I flip it over. So I might get a little bit of smell of burning insulation, but it'll be fine. There we go. All right. And there we are. So that's attached. And did we do that on the right side? Yes, good. Okay. So let's actually follow the directions here and match. Okay, so gray is attached to positive, so on the speaker I'll do the same thing. So I don't have to actually have to flip that around. I can just do this. Haha. Let's scoot it up a bit so you can see what we're doing. And I used my fingernails last time. This time I'll show you with the side cutters. We just snip that apart like that, right down the middle. And now we have two separate wires. that we're going to strip. Doing this with one of these, often they have a screw that you can put in here. Oh, here actually, there's a screw here that you can use to adjust how tightly it can close, and that way you can keep from completely snipping your wire. If it's a larger wire, I would move this screw in and it would only be able to close like that far. I can kind of do it by feel at this point. Having done this for a lot of years, I can kind of feel when I'm through the insulation on the wire. But if you're not super experienced, I might try instead using a, let me see if I can find one. Using a wire stripper that has little holes in it with different sizes. And then, that might be easier for you to not completely cut off the wire. So let's tin these. That, yes. That, yes. And I'm going to, these already look like they've got some solder on them. Are these even marked? Oh, they are. You've got like a little plus and minus on here kind of engraved into the plastic. So what did I say? Gray is plus, purple is minus. So we'll just do it this way. I'm going to stick it through the hole here for strain relief. Not a lot of strain relief, but a little bit. Let's get this all nice and melted together. Yes. There we go. That flux is really going. And we'll get this soldered as well. Might need to add a little bit there. We'll set this down for a second and sort of angle it so that it stays in place. There we go. Using gravity as our assistant here. There we go. Cool. Now, are we ready to make some noise? Let's find out. Solder socket U2. Match its dimple to the footprint just like you. Oh! We're gonna put the LM386 chip in. That is an amplifier chip, if I'm not wrong. So, when he talks about socket U2, U is usually the designation for a microcontroller on circuit boards, just like R is for resistors and D is for diodes. So like an LED will be listed as D. It's stuck to the tape here. Come out of there. Grr. U is often for microchips, and you can look up why that is. I feel like I've looked it up once or twice. It's something that doesn't make a ton of sense to me. Grr. Let's get this out of there. Tape is my enemy. It's gonna stick to everything. There we go. Okay. So we're gonna solder this in, and that dimple that he's talking about is this little divot in the top side here. You can kind of see that. And that's going to match up to one that's on the PCB here. And indeed it does. It's at the top there. And that little square indicates the location of pin 1. Also, pin 1 will always be sort of directly here underneath the dimple. So we're going to put that in there. I'm going to have to tack solder this on again because, again, it's sort of doesn't stay in there by a friction fit or anything. So I'm going to get a little bit of solder onto my iron tip here. Come here. Lead-free solder is a little bit more picky than leaded. Okay. So I've just applied a little dot of solder onto one of those pins. And actually that wasn't enough to hold it this time, so let's add a little bit more. Making sure to heat up both the pin and the socket. Ugh, why won't you do it? Okay, I think that's sort of done it. Yep, there we go. So now we have a very weak connection that we can exploit to solder in the rest of the pins. Yes, all right, cool. And then we'll just do all of these and come back and fix that one. There we go. Pavan asks, what microcontroller does this use? This is an Atmega. I believe it's a 32, or no, it's a 328, isn't it? Or a 128? one of the Arduino friendly ones, at Mega 328P. Yes. So this is a chip that can run Arduino code. So it comes fully programmed already, which is why it does that nice little LED flash when you first turn it on, like so. But you can reprogram it with Arduino if you want. So with the power off, I'm going to insert this chip. Again, the divot on the left here is going to match the one in the socket. And pin 1 is at the bottom left in that case. So let's see. Oh, there we go. Pretty easy. So what's the test here? We're going to power on, unplug your headphones, and press the switch. It should be playing out of the speaker now. Power off. All right, let's test. Oh, it does! Not actually SOS. Ignore that. Cool. Great. We have a Morse code player now. And that means that this works so far. Neocortex, error 404, user not found, says, I want to smell the solder burn. Ideally, we wouldn't be smelling anything. You should have a fume extractor, you know. Solder the remaining tactile 16 switches, SW3 through 18. We will all want them all as flat against the PCB as SW2, so take your time here. They should line up perfectly. Yes, this is the part that I've been waiting for. This is going to be so satisfying, putting all of these switches in. If you're just joining us, I am putting together the Oskitone Scout, which is a DIY-friendly synthesizer made by Tommy Marshall out of the Bay Area. And these are so cool. You can get it as a kit. You can get it assembled, pre-assembled by Tommy. And we have an interview with the creator linked in the description below, as well as the assembly instructions that I'm following. And I think that's a really cool way to sort of see what inspired Tommy, how he designed this, and then also some of the info about running a small business as a hardware entrepreneur and designer. I think that this, especially some of the stuff with the enclosure, is very cool. He's got this really nice, precise snap fit design that I think we'll get a look at in a minute. First, I'm going to solder all these delicious little switches. I love these switches. They're so satisfying. And we're going to have a fun little time playing with those later on. Haha. If anyone tells you this isn't a fun thing to do on a Friday night, they are wrong. Neocortex says, beep boop. Indeed, we are going to beep some boops. Okay. Honestly, inserting these in the PCB is just as much fun as like playing with them later on, because they have this really nice little snug friction fit with those little bendy legs that they have. Okay, time to do this. I'm going to be careful not to uninsert any of them. Okay. Marathon soldering. Let's get a good angle here. Yeah, here we go. Let's see how long this takes. It's 6:43 here now. We're doing about 16 of these switches. I'm using lead-free solder, as I mentioned before. It's being pretty friendly. I've got a Weller soldering iron here. It's a Weller SPG 40, and it's got some nice little fine tip on it, which actually has been holding up really well. I've accidentally left it on overnight once, and I was able to clean it up and decorrode it and stuff. So I'm really impressed with its sort of durability, and it's really a workhorse. It's got adjustable temperature. I've got it on at about 450 degrees Fahrenheit, I think, if that's what it corresponds to. It's halfway between 4 and 5. I could probably go a little lower, but it's nice with lead-free solder to have it really fast melting. I wonder if that one was perfectly aligned. Yeah, it's really nice with lead-free solder because just to have a little extra heat on there. Plus, as I noted, I'm not soldering any chips directly on this board. I'm not soldering to any chips. All of the chips on this board are plugged into sockets that I've soldered on. And so there's a lot less worry about accidentally overheating those chips. So I don't really have to worry about it. Let's push this one in a little bit more. Well, I guess it'll be fine. Everybody tell me what your favorite chip tunes are, or other music for assembling stuff too. I feel like chip tunes would be very appropriate here, but they're not for everyone. Not everyone loves a good square wave as much as I do. But that's fine. I'm working on, well, no, I'm not currently working on, but I'm ideating a 555 timer-based bass, which has been on my mind for years and years now. So when I saw Tolling's 555 timer-based polysynth, I was very excited because it basically uses the same principle that I was planning to do, which is having a separate 555 timer-based oscillation circuit, making square waves for each key. In his case, his is a keyboard. So I've decided that it's totally valid. Oh, that was a little much solder. That's fine. Yeah, my bass is gonna have like 4 so-called strings. What I've been thinking so far is using like soft potentiometers, which you can get from SparkFun. They're a little bit expensive and a little bit hard to work with. I've definitely burned some out in my time, but soft potentiometers to like emulate the bass strings, where you can slide your fingers up and down and it changes the resistance, and then it'll change indirectly the note that it's playing on the 555. Nearly there. A little bit more on this one. A little bit more on that one. And we're done at 6:46. That took us about 3 minutes. Not bad. Very satisfying, as I said. Okay, we've got a couple of capacitors left. But let's see what kind of a test we're supposed to do right now. Next is get louder. Oh, I see. Skip this step if it's already loud enough for you or whoever you're giving it to. Well, I think I want it to be louder. Solder cap C3, 1 microfarad. That's this one. Let's do it. More noise is always good. And it goes right here. And I believe it goes in this way. Well, let's just do a little check and see. Oh, that's very exciting. It totally works. Oh, that's great. Okay. Neocortex, yeah, check it out. I'm gonna move this. Actually, no, we'll make it louder and then you'll be able to hear it better. Haha. Okay, cool. So let's put this together. This little capacitor is supposed to make the whole thing louder, and then you'll be able to hear it better. One thing that I think is really cool in this is that it has this Portamento setting, or glide, where, when you push one key and then push another, it sort of slides between the two. If you just keep holding them down, which is cool. Instead of just doing a clean break from one note to the next, since it's a monophonic synth, if you push down more than one key, it'll just play whichever you push last, but it'll slide between them. Okay, let's see. That did make it louder. Oh, this is so exciting. That's so cool. I love it. Oh my gosh. I'm able to play the scale on here because I happen to know, which notes to skip to make it into a major or minor scale. Close enough. It sounds so good. Oh, I love this. Oh, I'm such a sucker for little beep boops. Okay, so prep for hacking. If you have no intention of ever changing the Scout's code, you can skip this part and it will work perfectly fine. But, you know, you're here, so you might as well. Okay, so let's solder the J2 header and C4 capacitor. So that's the final remaining little gumdrop capacitor that we have here. C4, we go there. And we're gonna stick a header in. Oh, I should turn this off. Whoops. Okay. That's C4, and then the programming header is this right angle header here. Stick that in there. Oh, I can text over that from the top. That's nice. Yes, there we go. Now that's going to stay in there. Try not to burn my case by flailing the soldering iron around. Always best when you don't have huge singe marks or melty bits on your synthesizer. I mean, it wouldn't be the worst thing in the world if I had to print another one of these. It'd be kind of cool, honestly, to make a little blue one. But I also love yellow, so... There we go. Okay, so that's preparing it for programming. There is a hacking section of the documentation on how to use that. And now final assembly. Oh, interesting. So I guess we're not going to use that other header? Interesting. So there is another header here that I've been using as my spot for the vice, and there are headers included. They say things like, oh, so it says hack and J3, jumper 3. So VCC, ground, switches 1, 2, and 3, SWC, whatever that is, maybe ground, no, ground anyway. I don't know what SWC is. Then we've got analog pins 0 through 5. That's very cool. Let me actually show you what I'm talking about here. Yeah, so this here, analog pins, switches, VCC, and ground, and you can stick that header in if you want to expand it with your own electronics, electronic doohickeys. That's a really cool thing to include on there. Oh, look, it's actually a little extra. It's got 2 extra pins on there. I wonder if there's a jumper here somewhere. Anyway, so this seems to work. We're going to do the final assembly. Very exciting. So, oh, look at this. What a great exploded diagram. So we're going to start from the top. We're going to put the knob in place. Like so. Oh, like so. The enclosure, the keys. We've got the keys and the mount bar already in there. Okay, so next comes the PCB. And then the battery and speaker and stuff are going to go underneath. So I'm going to... oh, boy. You know what? I'm going to leave that off for now. And I'm going to flip this over and put the PCB in upside down. Oh my. Are there like... Okay, so there's a couple things here. Nothing there. Mostly I just need to get that potentiometer in place. There we go! Ha! So easy! So then PCB, battery. I'm going to put the knob on last. The switch thing goes over here. This can be a little bit of a pain sometimes. Where does that go exactly? So, oh, I see. Oh, that's very friendly. I've done hacking on electronics with switches where it's been a huge pain to get the switch cover on because of how it was assembled. So it's very nice to see that this is not that way. Battery holder goes into the bottom, as does the speaker. So we're going to do this upside down again. Got you there. We can put the speaker here. I'm going to face it up so that it sounds nice. Wait, how is this? Really? Those? Oh, okay. Ah! Get back into place. Oh, I see. When I put it down, the potentiometer sticks up too much. Let's actually flip this over again and do it like it says to do. Okay, battery holder. And the wire doesn't say which side that's on, but I'm going to put it to the inside. Or maybe this way. That seems to fit well. Stick the speaker into here. With the cord coming out on the left side so that it goes into that slot. There's like a slot in the enclosure for that. I'll rotate it until it fits in there. Oh, perfect! It fits perfectly. Okay, how can I get everything to stay in place? Oh, there we go. Okay, and it should snap fit together. I'm just gonna give it a little wiggle or two. Try to snap it. Oh, what happened to our switch? Oh no! Switch, come back. Oh no! It's a little challenging. Okay, go in there. Go in there. Go in there. Go. Pursue. Okay. Oh, my. Oh, turn off. Okay. Gotta get this to sit in the right place. I think it's just it's a very like good snug snap fit. And I'm pretty sure that the PCB is in the right place. So I just need to be brave and kind of snap it together. There we go. Okay. That's one part. That's another part. Hey! It's kind of going. I didn't mess that up, did I? Go in there. I'm going to open this up again and just make sure that everything's still in place. Yep. Battery, everything. Maybe this little wire is getting in the way. Let's try and move that around a little bit. Sometimes things are close, but not quite there. This is the most harrowing part, to be honest. Ah! Okay. I think we're there. I think we're getting there. Did I speak too soon? No. I think it's good. Oh, why is that? Oh, that key is trapped underneath. Trying to get that key popped out. Why are you doing that? Why are you doing that? I don't know why this particular key is being a jerk. What is your problem? I need you to come out the top without breaking, ideally. There we go. Ah, ha, 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 ha. I think that might have been the problem. So the switch is still in place. Let's get that lined up with the actual PCB switch. Ah! Oh, the other key is also mad at me. Come out the top here. Are they actually supposed to be out the top, or are they supposed to? I don't know. Yelling always helps. And making little feral noises. Okay, come on. I know we can do this. The switch is in the right place. Everything else seems to be fine. We're gonna go around the edge here. Squish it together. Okay. Making progress. Progress, come on. Okay, that works. I don't know why this one key is just being a jerk. Maybe it's over too far. What is your problem? It pushes down. No, it's stuck in place. Physical assembly, having some problems. We're nearly at the end here. It's the final stretch. We're gonna pry this apart again and try one more time. What could possibly be causing that? Is this little bar not pushed in all the way? Maybe that's the problem. But why is that one key? Why is that one key just refusing to cooperate? Don't understand. Let's take it apart. Okay, so here. When it's all apart in its own components, everything's fine. Okay. Is this warped? Oh, this is a little bit warped. Okay. I think there's our problem. It's a little bit curved. Yeah, when I put it on the desk, it like wobbles a little bit. Okay, so I'm going to flip this upside down and hope that that fixes it. We may get an issue with the ones in the middle now, but at least all the ones on the end should be fine. Okay. So stressful and yet so exciting. What happens if I put this down on there first? Oh, that was probably a better way to do it, huh? Oh, and then we have that wire there. We have this wire here. What's going on with this? Why is it rocking like that? Maybe that's our problem. Ah, there we go. Now it's all seated. You're seated in there. So maybe if I did this again, I would do it from... like actually doing it the right way up, like is suggested. That key looks okay. Our troublemaker seems fine for now. Cross your fingers for me. Oh, it takes a lot of pushing, but that's because it's a very secure snap fit. It's not just gonna fall apart in your backpack. Assuming I can get it together in the first place. Get it together, Alex. Ah, there we go. Okay. Come on. Oh. Hey, that might be it. That might be it. That's right. Oh, this one isn't going now. That's beautiful. Okay, it seems like I have a couple of things to work out with the, let's try and put this in a good spot so that it matches up with where the potentiometer goes. I'm a perfectionist here. There, that's about even. Okay. Yeah, it seems like there's a little bit of finickiness with the construction here. Like this one doesn't want to go. I'll monkey with this some more on my own time and hopefully come back and give you a fully working demo. It seems like something about the way that I'm putting this together is causing some problems. I might have skipped something, or maybe something else is going on. But yeah, very excited and happy about this synthesizer. Once again, this is the Oskitone Scout, and I'm very excited to have finally put it fully together. Go check out the interview with creator Tommy Marshall, who has created not only this synthesizer, but a bunch of other ones under the name Oskitone. There's a bunch of different kits that you can get, either for yourself to assemble or pre-assembled. And there's also part one of this assembly. There's also a link to Blitz City DIY's page, whom we're going to have on the interview show on Tuesday in a couple of weeks. And yeah, all kinds of cool stuff. And there's also a link to the GitHub page where you can get the files to build one of these for yourself. Or you can build it. You can buy a kit, you can get it assembled, or you can even go find the original files and hack it to pieces and build exactly the synth of your dreams. So this is a very cool thing. Thank you so much, Tommy! And I hope all of you have enjoyed sharing this Friday night with me. Thanks for joining me. It's good to have the company. And yeah, have a great rest of your Friday and a good weekend, whatever time. It could already be your weekend, but yeah. We'll be playing with this some more. Hack on.